Lesson: Strategies for Reducing Bias in AI Systems. Bias in artificial intelligence systems is a critical concern that professionals in the field must address to ensure ethical and fair outcomes. Bias can manifest in various forms, including gender, racial, and socioeconomic biases, and can lead to discriminatory practices if not appropriately mitigated. Strategies for reducing bias in AI systems are essential for creating equitable and trustworthy technologies, especially in high-stakes domains such as healthcare, finance, and criminal justice. This lesson explores actionable insights, practical tools, and frameworks designed to identify, measure, and mitigate bias in AI systems, offering professionals a structured approach to enhance fairness and compliance. One primary strategy for reducing bias in AI systems is the implementation of diverse and representative datasets. Bias often originates from training data that lack diversity, leading to models that perform well on certain demographics but poorly on others. Ensuring that training datasets represent the full spectrum of the target population is crucial. This involves collecting data from various sources and demographics to avoid overrepresentation or underrepresentation of any group. Professionals can employ tools such as IBM's AI Fairness 360, which provides metrics to evaluate the balance of datasets and offers techniques to rebalance them if necessary. Another effective strategy is the use of fairness-aware algorithms. These algorithms are designed to incorporate fairness constraints during the training process, reducing the likelihood of biased outcomes. Techniques such as adversarial debiasing involve training models to predict outcomes while simultaneously ensuring that the predictions are independent of sensitive attributes. The Fairness Constraints Framework is another tool that allows professionals to impose fairness constraints directly into the optimization process of machine learning algorithms, ensuring that the model's predictions meet predefined fairness criteria. Bias audits are an essential component of ensuring fairness in AI systems. Regular audits involve systematically examining AI models and their outputs to identify and address potential biases. This process can be facilitated by using frameworks such as the fairness, accountability, and transparency in machine learning principles, which provide guidelines for conducting thorough audits. These audits should be an ongoing process, as models can drift over time, and new biases may emerge as the underlying data changes. Incorporating human oversight and interpretability into AI systems can also help mitigate bias. Human oversight ensures that AI decisions are monitored and evaluated by human experts who can identify and correct biased outcomes. Interpretability techniques, such as LIME, provide insights into how AI models make decisions, enabling auditors to understand the factors driving predictions and identify any biased behavior. This transparency is crucial for building trust and accountability in AI systems. Stakeholder engagement is another critical strategy for reducing bias. Involving diverse groups of stakeholders in the AI development process can provide valuable perspectives and identify potential biases that might not be apparent to the development team. This collaborative approach can be facilitated through participatory design methods where stakeholders contribute to the creation and evaluation of AI systems, ensuring that their needs and concerns are addressed. Case studies illustrate the effectiveness of these strategies. For instance, a notable example is the Gender Shades Project, which highlighted significant racial and gender biases in commercial facial recognition systems. By evaluating these systems against a diverse data set, the project revealed that darker-skinned females were misclassified at rates up to 34.7% compared to 0.8% for lighter-skinned males. This study underscored the importance of representative data sets and prompted companies to enhance the fairness of their algorithms. Real-world applications also demonstrate the utility of bias mitigation tools. The Compass recidivism tool, used in the criminal justice system, faced criticism for racial bias against African American defendants. By applying fairness-aware algorithms and conducting bias audits, practitioners can ensure that such tools produce equitable outcomes across different demographic groups. Statistics further emphasize the need for bias mitigation. A study by MIT found that AI systems used for recruitment showed a 20% higher bias against women compared to men, highlighting the potential for discriminatory practices in AI-driven decision-making processes. By implementing bias reduction strategies, organizations can prevent such disparities and promote fairness. To effectively reduce bias in AI systems, professionals must adopt a holistic approach that integrates diverse datasets, fairness-aware algorithms, regular bias audits, human oversight, and stakeholder engagement. These strategies, supported by practical tools and frameworks, offer a comprehensive solution to the complex challenge of bias in AI. By applying these techniques, professionals can enhance the fairness, accountability, and transparency of AI systems, ensuring ethical and equitable outcomes.